Hello everybody, my name's Andrew. Have you ever played with a slinky when you were little? Something like this? Or even dominoes. It's really similar to the transmission, to your nerve cell transmission of a motor neuron. Nerve transmission signals are just like these. All things must be in order for one signal to go from one end to another. If something's missing, the signal stops and there's no signal. There are many types of neurons in the human body, but for this I will go over the multipolar motor neuron. We will discuss the anatomy or the parts, the physiology or the function, where they're located, and what happens if they're missing in your body or destroyed in your body. First, let's take a look at the anatomy. The anatomy starts with these dendrites. These fingers here on the cell, these are dendrites. These dendrites receive signals from other motor neurons or other neurons. This is your cell body. This is your nucleus, just like any other cell has a cell body and a nucleus. This right here is an axon hillock. The axon hillock is very important for the physiology, which I will get into next. But anyways, your axon hillock is right here. This is your axon. This is the myelinated sections of your axon. That's actually, the more myelination you have in an axon, the quicker and faster the time that it receives it to the time it sends it out. This is your terminal ends. This is where it actually sends it out to your neuromuscular joint or your muscle or your next neuron. Now that we've done a crash course in anatomy, let's go over physiology. The physiology, when the dendrites receive the signal, the cell is basically the integrator. It will decide on if it's got enough signals from all these dendrites, because it may have signals here and no signals here. If it's got enough signals, the cell body itself will determine whether or not to keep that signal going. If it does, the first thing it's going to do is it's going to cause an action potential at your axon hillock right here. And what this is you got two different voltage channels. You got a sodium channel and a potassium channel. And these channels open. Your sodium channel will open, allowing sodium to enter the cell. These are all would be right on the surface, the membrane, the surface of the cell. Anyways, the sodium gate would open, allowing sodium into the cell. And then the potassium gate would open, allowing potassium out of the cell. And this would cause a voltage wave. It's a millivolt wave, but this causes a millivolt wave, and it runs the whole length of the axon, which in turn causes electrical signal or transmission down your nerve, and it actually will tell your arm to move, or your leg to move, or your neck to turn, or even organs to work. It'll send it down to the terminal ends, and the terminal ends have another transmission that I won't get into because that's longer than what we're doing here. But now that we know the anatomy and the physiology, how about a couple what-if scenarios? What if your neuron was split in half? Well, you could cause numbness. It could cause paralysis. If it's in the right spot, it could even cause death. Some of these areas where these motor neurons are located, a lot of them are where they put output signals to your muscles to move your muscles. If you had a motor neuron to your arm that, for your thumb, and that motor neuron was messed up, you may not be able to move your thumb. You may be able to physically move it with your other hand, but not with your mind. So anyways, hopefully I gave you a broader outcome on the anatomy and physiology of a motor neuron, maybe a little more interest. Thanks for coming. Thank you very much.